Let's begin. Today's September 29th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 2, 7, 12, 18, 19, and 20. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at our first digit, the triangle digit, and compares it to the number 3. So should the value of triangle be less than 3, should it be equal to 3, or should the value of triangle be greater than 3? Criteria card B looks at our last digit, the circle digit, and will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at our first and last digits, triangle and circle, and compare them. So should the value of triangle be less than circle, should it be equal to circle, or should the value of triangle be greater than circle? Criteria card D will take a look at our 3 digits, triangle, square, and circle, add them up, and the Turing Machine will let us know whether the sum total is an even quantity or an odd quantity. Criteria card E will take a look at our first digits, triangle, square, add them together, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F will take a look at the 3-digit solution and will let us know a little bit about its structure, so to speak. Specifically, there are 3 scenarios. One is where there are no repetitions, as in the example 1 to 5. Or it could be a double number, a repeating digit, as in the example 112. Or it could even be a triple number, a single digit repeated 3 times, as in the example 222. And remember, the objective of today's puzzle is to find that one unique code that abides by all of the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to test is criteria card B. I want to know a little bit more about that circle digit. Okay, so the Turing Machine does not approve of my choice. I did pick an even 4, but since the Turing Machine does not approve of that, it's actually letting me know that circle should actually be an odd digit. So let's go ahead and type that up. So in section B, we'll say that circle is an odd digit. And since it is odd, let's go ahead and cross out the evens, 2 and 4. Next, I think I'll test criteria card D. Okay, so again, the Turing Machine does not approve. Notice that in criteria card D, we are adding all the digits together. So let's go ahead and do that. So 3 plus 1 is 4. 4 plus 4 is 8. That is an even quantity. But again, since the Turing Machine does not approve of that, it's letting us know that the sum of the 3 digits needs to be odd. So let's go ahead and type that up in our notes in section D. And that again is that triangle plus square plus circle should be an odd quantity. So let's see what we can say about that. So we do know that a circle is already an odd digit. So that means that triangle and square need to add up to be an even, since an even plus an odd does produce an odd value. So that means that triangle and square are of the same type. They're either both even or both odd. So we're looking at a potential even, odd solution or an all odd solution. And let's go ahead and then test criteria card F. Okay, so again, the Turing Machine does not approve of my proposal. Notice that 314, there are no repetitions, but the Turing Machine does not agree with that. So we're looking at either a double number or a triple number. So let's go ahead and type that up in our notes for section F. And we'll say that the solution is a double or triple number. And I'm not sure there are any clues that could distinguish between a double and a triple right now. I just don't see anything that would disqualify one or the other. Well, I guess perhaps, if we knew it was a triple number, then obviously triangle would equal circle, since all digits are equal. So I think maybe that is our clue to be able to disqualify the 3-digit solution as being a triple number, since it would make criteria card C irrelevant. If we had a double number, that's not necessarily the case that triangle equals circle. It doesn't have to. We do know that two numbers equal, but not necessarily triangle and circle together. So I won't cross that out right now, but I am definitely leaning towards the solution being a double number. Okay, well that does it for this round. We completed our 3 Turing tests for round 1. Now we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice that we did not test criteria card A, comparing the first digit to the number 3. We also did not test criteria card C, comparing triangle with circle. And of course, we did not test criteria card E, where we're adding the first 2 digits. So if we do have a double number, it could be the case where, triangle maybe equals circle. That's plausible. And so what would that mean? We would be able to tell what it is from criteria card A once we resolve what triangle is. Let's see, what else? But again, we're not sure, we're not sure if triangle and square are both even or odd. If it were an all odd solution, triangle would be odd, circle is odd, and square would be odd as well. I'm just not sure. Again, we can go back to the possibility that the first 2 add up to 6. Could we somehow figure out if they're both even? Is there any clue? Because you could have, well, no, we can't. Actually, that's a good point. We can't have triangle and square add up to be 6 and be even. Well, no, I guess we could. Because criteria card C will just let us know what the odd is. But how would you know they'd be even, as opposed to, both being odd? Like 1, 5. I'm not sure. But somehow, we do have a double. I guess, let's see. Hard to tell. Again, we could have an all odd solution. If indeed triangle and circle are equal, that would definitely maybe point toward an all odd solution. Yeah, let's go ahead. Let's see. Let's try something like 535. I'm thinking that maybe, yeah, triangle and circle are equal, but perhaps their sum is going to be greater. I'm not sure. So let's go ahead and try 535. Okay, so I did want to test criteria card C to see are they equal, triangle and circle. Okay, yeah, they are equal. Okay, so let's go ahead and type that up, and that is in section C, and we're stating that triangle is equal to circle. So I think that conclusively proves that yes, it is an all odd solution. Since circle's odd, triangle is odd. So far we've got two odds. If we want the overall sum to be odd, then that means they're all odd. So let's go ahead and cross out the remaining evens in triangle and square. So we are dealing with an all odd solution where the first and last digits are equal. So I guess the next test, let's go ahead and test criteria card E, the sum of the first two digits. Okay, that is also true. And so let's go ahead and type that up in our notes for section E, and that is that triangle plus square should be greater than 6. Since the Turing Machine approved of my proposal and the sum of my first two digits, 5 and 3, are 8, 8 is greater than 6. So yes, the first two digits need to add up to be greater than 6. So that means that we can actually cross out both 1 for triangle and square, because 1 plus even the greatest of 5 would be equal to 6. So let alone need to be greater than 6. So yeah, we can cross out the 1 for both triangle and square. And so now, yeah, it does seem to be that the first two digits have to be 3 or 5. We just don't know the order. So let's go ahead and test criteria card A. Okay, so that is also true. That is, I have 5 for triangle, and since 5 is greater than 3, yeah, it's true that triangle should be greater than 3. So let's go ahead and type that up, and that was section A. And so, yeah, triangle needs to be greater than 3. Of course, that means that, yeah, triangle is actually the 5. And that would mean that circle is a 5. So that means that it can't be anything else since they are equal. So let me go ahead and do it this way. Cross out the 2, and then we'll, of course, 4 was crossed out earlier. Okay. Okay, so we've got our triangle, and let's see. Again, going back to criteria card F, do we have a double or triple? I guess I believe it's a sound argument to make, again, where if it was a triple number, we would know automatically that triangle is equal to circle. So making C irrelevant. So let me go ahead and cross out the triple. And we are saying that it's a double, so that means that square cannot be the 5, leaving square to be 3. So let's go ahead and type that up in our notes as the solution being 535. Okay, and let's go ahead and test or confirm. All right, 535. Okay, yeah, that's exactly it. How do we do versus a Turing machine? I believe we did test all 6 criteria cards. Yeah, so it's a good chance that we at least tied versus a Turing machine. First round, we tested B, D, F. And in the second round, we tested all the remaining cards. And in each case, we've got, in the first round, we got them all incorrect. Second round, we got them all correct. So BDF in the first round. So BDF. And then ACE. How do we do? Okay, so we beat the Turing machine by 2 questions. So again, just a lucky guess on specifically criteria card E, that the sum probably wasn't going to be even. It was hard to tell that we could have 2 evens in triangle and square, and so I just went with an all odd solution, and it just happened to hit. Well, how did you solve? What criteria card order did you use to solve, and did you find anything interesting that you'd like to share? Add those thoughts to the comments. If you liked the video, please give it a thumbs up, and of course, hit subscribe so that you don't miss out on any future videos. Well, until next time, have a great one.